This is the senior design video for Team PJ4 of ECE 4960 at Clemson University. For our project, we were required to create a table complete with motorized juggling arms capable of juggling ping pong balls across a planar surface. Some additional requirements are as follows. The system should be able to juggle a ball at a stable position for several minutes. The system should track the ball in real time using a PlayStation Eye camera and computer vision code. The system should have a way to recover the ball if the arm loses it. And finally, the system should have at least 2 additional actuators and the ability to perform tricks using them. To support our design, we constructed a 48 by 48 inch wooden table set in an incline. We decided to have 2 aluminum juggling arms driven by 12-volt DC motors installed directly through the board. The PlayStation Eye camera was mounted on a beam hanging in front of the board, and the tracking code was managed in Visual Studio 2015. To handle recovery of a ball, we included a third DC motor with a 3D printed paddle as a launcher. In case multiple balls needed to be launched, we also used a 12-volt push-pull solenoid as a gate in front of the launcher. To control the motors and solenoid, we built a Simulink model onto a Tiva microcontroller. This model governed the position control of both motors by summing encoder feedback and reference angles into PI controllers. Reference angles were sent to the Tiva via UDP port communication from a USB connected laptop. Also, this model sent on-off commands to the solenoid gate and launch motor using the GPIO output pins on the Tiva. In operation, the system was able to perform a single, stable ball juggle for several minutes at a time. When a ball was dropped during a juggle, it would roll in front of the solenoid gate. Once camera tracking lost the ball, a timer would start. The gate would then open, and after a few seconds it would close again. The launcher would start automatically after this, and then stop once the ball re-entered the frame. The gate and launcher controls operated correctly, but there were some avoidable issues with the system. First and foremost, one of the 2 juggling motors suffered internal damage during operation, so the system was eventually reduced to 1 juggling arm. Likewise, the launching motor was very inconsistent. As the launcher did not have an encoder or position controls, launches would vary greatly with the starting position of the paddle. Sometimes it would hit a ball back towards the gate instead of carrying it upward. Lastly, the final system was not able to perform additional tricks with the juggling arm. If given a chance to improve the system, we would implement a transfer function to smooth the set point angles set to each motor. This could potentially have prevented the juggling motor from breaking by giving it easier to track coordinates. Likewise, we would add an encoder to the launcher so that its starting position would always be the same before launch for consistency. Given more time, we would refine the code to allow the juggling arms to pass a ball back and forth as a trick.